For centuries, humans have always looked up at the stars with curiosity, examined the origin of these shining stars and their bewildering mysteries. Such a question, since the dawn of human civilization, it has become a religion, the focus of philosophical and scientific debates. History, many outstanding thinkers in the field of science have addressed these issues, gave his own answer, and put forward various theories. These theories sometimes contradict each other. One of the most well-known and widely accepted theories, the Big Bang Theory, without a doubt, however. The theory is well known. The degree does not bring about its authenticity, deep understanding of meaning and scope. Even some experts in the field, there are also major misunderstandings and misconceptions about this. The most common misconception is that many people believe that the Big Bang Theory can explain the origin of the universe. Actually, the Big Bang Theory is about the universe. How is it that from a hypothetical extreme, high-density, high-temperature states begin to evolve? He also explains to his disciples the creation process of the universe. How did it start? Or before that, what are the possible events? Let alone explore what we know today beyond the universe. Is there anything else unknown? Another serious misunderstanding, and people will explode with some kind of huge bombings are linked. In fact, the Big Bang Theory describes the universe, the process of expansion that begins in a primitive state, and suppose the universe expanded to the scale now observed. Although the theory describes space expanding at an unimaginable rate, it might even exceed the speed of light. But this process, it cannot be regarded as an explosion in the usual sense. What you need to remember is that no matter how grand the theory may be, he is still a physical number. Academic vision and may also be challenged by future discoveries. The current universe appears to be made up of countless interstellar. Each bit of light could represent a galaxy. Each galaxy contains hundreds of billions of stars. The attractive forces in the universe form a network of filamentous structures. Through dark matter and gas formed invisible bridge linking galaxies and galaxy clusters together. This structure can span hundreds of millions of light years, formed over billions of years, and this network of galaxies is all over the place. The entire universe, and it expanded in all directions. In these galaxies, some of them are spirals. It contains bright stars. Like many other stars, there are 8 planets orbiting this star. Rotate around it. On one of the planets, there lived a species that until recently creatures who have just begun to explore the mysteries of the universe. The discoveries made in this century, more discoveries than have been made in the entire history of mankind. Actually, we do. Everything that exists is made up of from nuclear reactions inside stars. Stars burn hydrogen and transform it into heavier elements. Without these elements, everything we see won't exist. But where do stars come from? Who created them? Which brings us to the eternal question. We need to find the original reason why all things began, even facts beyond our comprehension. We believe that the entire universe, including all galaxies, time, space, and nature, it's all built up from scratch, and we were baffled by this idea. But we have to stick to the scientific method. Only talk about what we have the potential to prove. Our goal is to understand the universe. How does it work? And how it came to be, and the only way to achieve this goal. It depends on those who can bringing us information about the light from the universe, because in this light are hidden stars. Information protection for nebulae and galaxies. Without this information, we can't imagine their true nature. When the invention of the landscape and the spectroscopy that came with it opened the door to modern astrophysics. The bright spots we observe in the night sky, although it may just be the universe without a fraction of the pore, but they are enough for us to understand the past of the universe, present and future from the Earth. All these galaxies we've discussed, it's part of the fabric of the universe. They are filled with the secrets of the universe. Cosmic density, it's a network of filaments glowing red, as if we were passing through a pair of tinted glasses to observe the universe. This detail reveals to us, shows the mystery of the birth of the universe. There's a wealth of information in light we need to decode. One of them is about motion of objects in space. The light waves emitted by the objects we observe, depending on how far away the object is, close to us or close to us, and a red meter or a blue meter occurs. This phenomenon is known as the Doppler effect. The red meters are moving away from each other. This means that the universe is actually expanding in every direction. The speed of this process is described by Hubble's law. For cosmologists, realizing this is like hitting the jackpot. They are eager to know about this expansion. When did it start? If you turn back time in the early days of the universe, the distance between Xingxi is closer video. By rewinding time, we go back about 13.70 billion years. Then the universe we live in today compressed into a tiny region of space. The point under this extreme condition is called the starting point, to emphasize that he is beyond the norm. The particularity of the laws of physics characteristics of the starting point is of infinite temperature and density. You can imagine the starting point as a massive black hole. But there is a reason common myths about the universe. It should not be assumed that all matter in the universe are compressed into a single point, because the starting point of the Big Bang was actually caused by made of pure energy. It doesn't even contain matter. No attractive force, because of the four fundamental forces of interiors, electromagnetism. If the interaction force is strong, the interaction force and attractive force may also be separated. It remains a unifying force. How long did the starting point exist? And what triggered him? There are still no definitive answers to these questions. But suddenly the starting point undergoes a huge expansion. In an instant universe, in a second, from the size of an atom, it's as big as an orange. And so the universe began to exist. A journey that expands and unfolds. It gets bigger and bigger. In the next 100 seconds, the universe gradually began to cool and expanded rapidly to the size of our solar system. In the process, the energy starts to cool down and convert it into billions of subatomic particles. These particles extend for billions of kilometers. About half of the particles are composed of the same composition of matter, and the other half, it is formed by the relative matter called antimatter. When matter and antimatter meet, they will be in a process called smoke extinguishing, annihilate each other. Therefore, the birth of the universe was accompanied by the disappearance of a large amount of matter. Fortunately, the amount of matter is slightly greater than that of antimatter, and that allows matter to survive. Even if this survival is only a 1/100,000 difference, it is this tiny difference provided the origins of the universe as we know it today. As time goes by, rough stone plasma in the universe initially is evenly pushed and extremely hot, but he started to form little vortices. It gets denser. About 1/100,000 second after the Big Bang, the temperature is low enough. It's about 100 billion degrees. This is hotter than the quarks inside the sun, 1 million times higher. After approximately 1/1,000,000 seconds, protons and neutrons begin to form in groups of 3. In the next 3 minutes, particles in cooling form plasma start making some of the lightest elements in the universe, atoms like hydrogen and C, and condensation. As the temperature of the universe gradually decreases to 1 billion degrees, it not only forms a large amount of hydrogen and C nuclei, it also produces a small amount of heavy hydrogen. This period is known as the primordial nucleosynthesis period. At the end of the first 10 minutes after the birth of the universe, the diameter of the universe has expanded to several light years, and in the following approximately 300,000 years of continued expansion and cooling, when the temperature drops enough to make electrons slow down to can be nucleated, mainly the degree of hydrogen and harmful capture the atoms that formed the first electrical center, it was a turning point. Because before that, the universe is composed of a dense plasma composed of charged particles. The motion of these particles is constantly hindered even the shortest distance, nor can it be absorbed, or it moves with deflection, would leave the universe in a completely opaque state, as if shrouded in darkness. However, when subelectrons start orbiting the positively charged atom to form electrically neutral atoms, the barrier between electricity and electricity has disappeared. The fog began to lift. The photons created in the Big Bang were able to travel freely. With the release of pressure, the universe became increasingly visible. Matter no longer exists as a fluid. They start to clump together and form lumpy structures. Marks the beginning of the process of star and interstellar formation. We have entered the material age. Here it is, a complex and not yet fully understood process. In about 5 billion years, the galaxy sea clouds gradually thickened in space. They formed these enormous structures, ultimately formed what we see through telescopes today, the observed scene of the universe. The first stars ignite their big blue stars. Put hydrogen, the core furnace that converts energy and light into harm, but the lifespan of these stars is not infinite. Once the nuclear fuel runs out, the huge attractive force compresses matter to the extreme, reach incredible temperatures and densities. Therefore, heavier elements such as iron, gold, lead, and oil created in the hearts of these stars When the rampage explodes, new stars are born from their ashes. The first blue giant star went supernova. The explosion was as brilliant as the entire galaxy. There remains a cloud of boiling gas formed in space, rich in all known new nebulae of chemical elements, and the atoms in these nebulae and other form neutron stars and black holes. As time goes by, new stars are born in history. Our solar system is one of them, born out of the regret of a supernova explosion. We humans who live on this planet, it's part of the evolution of the universe. Born from the ashes of these stars, in less than 4 centuries of scientific exploration, we have uncovered this part of history, many secrets that in itself is a remarkable achievement. In exploring these ancient and fundamental questions, we seem to have exposed the mystery of the birth of the universe, analyze its structure and operating mechanism, even to its possible end. There are some predictions. It seems that only a few details need to be added. Mysteries and surprises seem to have been revealed. However, is it too early to declare science the end of internal discussions in the field of science? Seems to be a trend. This phenomenon, to a large extent due to the tremendous success of science itself at the end of the 20th century, under the outstanding integration of Maxwell, showing its elegance and brilliance. Mechanics and thermodynamics have also come of age. People used to think that scientific exploration was coming to an end. Even the great physicists thought, your work is about to be completed. The future may only be in cultivating the ability to pioneer genius in a new field. Students, however, just a few short years later, emergence of relativity and quantum mechanics completely overturned the so-called classical physics, proved the mysteries of nature far beyond our imagination. In the cosmology of physics, no such concept. Maybe it's just a theoretical idea rather than the reality we can observe. Always, we're constantly pulling all the energy out of the universe. The universe will still not become empty. The currently observed universe everywhere is teeming with matter-radiated antimatter neutrinos, and the mysteries measured dark matter and dark energy. Even if we try every bit of energy in the universe can still create new forms of energy. The reason for this phenomenon, as if to tell us the universe itself does not accept the idea of total nothingness. Suppose we do remove all the energy, leaving only empty space. According to our expectations, the universe should reach absolute zero. There are no examples. But the truth is unexpected. Even though we think the universe is empty, the expansion of the universe still generates radiation. This radiation can continue into the distant future, even going back further than the universe, the hot period before the Big Bang. This proves that universe forever far from being truly empty of nothing. So, is it possible that the universe was created from nothing? We are sure. Even as we move out of space, all particles, after antiparticle photons, and quanta, so-called empty space, still exists. In this empty space, stay away from any mass or energy. No external electromagnetic field and attractive force field prevent the entry of photons or attractive force waves, but the state of nothingness in physics, the quantum field, still exists. This implies fundamental maturity, and the laws of physics and the inherent zero-point energy still exists, even if it has limited positive and non-bullying values. That's probably what we can do in space. The closest state to nothing, but even so, that doesn't mean physical nothingness. You can't create that in a lab. Therefore, from a scientific perspective, we can say something in some form has always existed, because in our universe, true coexistence is impossible all the time. But when we try to explain why does this happen, current science is not yet in the universe of the universe. Give the answer, and it's a very complicated thing. Observe from any angle, the universe is anything but empty. We see stars, gas, dust, other galaxies, galaxy cluster, quasar, cosmic rays, even from stars' light, and the radiation from the Big Bang itself. If we had sharper eyes or more advanced detection tools, we can also detect those that we know exist. In the signal includes attractive force waves from any mass source. These attractive force waves are accelerated by changing attractive force fields from the elusive signals that make up dark matter and more. Research on active and dormant black holes, comprehensive understanding everything we observe, all take place in an evolving universe. From a physical point of view, the universe is constantly expanding and evolving. Understanding our universe, how can it change on a large scale, is very attractive. What we call the structure of the universe. Space-time is expanding. This means that if we are in calibrate two distant points in space-time, as time goes by, the appropriate distance between these 2 points, the time it takes for light to travel between these 2 points, and the wavelength of light that travels from one point to another will increase. The expansion of the universe is more than just an expansion. It's accompanied by a cooling process. When the wavelength of light extends longer, it will shift to lower energy and lower temperature. The universe was hotter in the past, and in the future it will get even colder. In the process, the universe contains mass or energy. Objects attract each other, formed a promoting structure, and created a vast cosmic web. If it can be removed in some way, all matter in the universe, all radiation, and every bit of energy, we still leave empty space itself. The space is still expanding and still obey the laws of physics. Physicists are also subject to the influence of quantum fields throughout the universe. This represents, as far as we can go, the closest physical gold wire to a true state of nothingness, but he was still following certain rules of physics. Four physicists in the universe take out anything else will create a relationship with us, inhabited universe, no longer corresponding impractical state. This means that as we currently understand and energy, even under this hypothetical, in a theoretical universe, with nothing, it still exists. If you take every quantum field in the universe, adjust to the lowest energy state, you will reach the zero energy state of space. This means that in such a universe, energy, the zero-point energy of the cosmological constant or quantum factory, you can't extract any more energy from it. Any form of mechanic, no reason. Suppose the zero-point energy is really zero. As the universe continued to expand and cool in the distant future, radiation will become beyond others, all forms of matter, and the main components of radiation. Only dark energy is more prominent, but this property of the universe, not just in the future, exists in the distant past. During the expansion of the universe, except for matter and radiation, there are other factors that dominate. Before the hot Big Bang, our universe has gone through an incredible period, a period of rapid and constant expansion. This period, the universe, is not dominated by matter and radiation. In the early 20th century, Alexander Friedman, based on Einstein's general theory of relativity, a major breakthrough has been made. He brings a theoretical insight, and three key observations came together. He found a universe filled with matter and energy in any form can't stay static. It has to be expanding or contracting, and this expansion or the rate of contraction is determined by the overall energy density of space. Henrietta Litt, through its observational work, established magnitude cycle and the relationship between the intrinsic brightness of a side variable star and period photometric relationship. Wistislev, through observation, a red meter that measures light in extrasolar nebulae, or blue meter change. These nebulae were later identified as galaxies. These observations show that these galaxies is moving away from us at an incredible rate. Edwin Hubble and Milton Hugh is busy with these spirals and ellipses. Henrietta was discovered in the nebula, the same type of variable star that Leavitt studied, enable them to measure the distance to these galaxies and confirm the fact that they are located outside the Milky Way. These four important findings together: the universe is expanding. The formation of ideas. If the universe is expanding, this means that over time space itself is expanding. Make the matter in the universe sparse, due to the fact that matter is composed of a fixed number of particles, but the space occupied, it gets bigger as the universe expands. So the universe is getting sparser over time. Radiation, such as photons or light waves, not only will it dilute to a lower density, and as space itself extends to greater distances, the energy of each light wave also decreases, cause the universe to not only expand and dilute, it cools down. If we pass reverse time to consider the matter in the universe and the state of radiation, the opposite will happen in the past. When the universe was younger, he will be more lethal. Imagine all matter and radiation are compressed to a greater extent in a small volume, make the universe denser. Going back in time, light waves, stretched by the expansion of the universe, tend to shorten. This results in higher temperatures and a hotter environment according to the laws of physics, and eventually you reach a starting point. All matter and radiation shots are compressed to an infinite density and temperature in the point of degree. The original concept of the Big Bang led to 5 basic predictions about the hot and dense state of the early universe, and these predictions became the cornerstone of the Big Bang theory. First, the universe should be expanding. This can be past observed star, a clear redshift distance relationship between the lines. To prove, secondly, the universe should start from something like stars. Groups of galaxies start as time goes by, galaxy clusters and vast cosmic webs, gradual formation and evolution. Third, the universe should have been hotter in the distant past, reached a stable medium the temperature at which type atoms cannot form. This led to the observation of the cosmic microwave background radiation prediction, the extreme heat of the early fourth universe. Hydrogen elements such as hydrogen high tenderloinates isotopes should be formed in specific proportions finally. The universe was hot enough. Neutrinos in the early universe played a key role. This prediction was recently confirmed. Neutrinos in the universe should be structured at large scales, and the Big Bang, leaving detectable traces in residual radiation. All five of these predictions all have received strong observational support, make the Big Bang theory became the dominant theory explaining the early universe. Beyond question. Universe Weibo. In the 1960s, the discovery of background radiation for the hot Big Bang theory provided strong support. However, in the 1960s and 1970s, as more evidence accumulated, some puzzles emerged. These puzzles suggest that Big Bang theory unable to fully explain certain observations. These results and the universe originated at an extremely high temperature and density. States of a single universe seems contradictory. Three of them stand out in particular. The first is the problem of the horizon. We observe looking from different directions. The universe shows the same temperature and density everywhere, but according to the hot Big Bang theory, since the Big Bang between these regions, there is never enough time to exchange information or achieve thermal equilibrium. So how did they evolve to have the same temperature and conditions everywhere? Secondly, the video tandem problem between the initial expansion rate of the universe and the attractive force. There seems to be a perfect balance. This generates a spatial and completely flat universe. Here's the thing. Why was our universe born? Have these specific properties. The third is about strange ruins, missing predicted by theory. If the universe reach arbitrarily high temperature and energy conditions, you should be able to observe right-handed neutrinos today, and strange ruins like Tsudan Yoshiko. However, these examples do not exist as expected with it. Simply accepts these conditions as the universe way of birth. It parallels the scientific method. Scientists seek a mechanism to explain these initial conditions. Solutions to these cosmological puzzles. In 1980, Eugene proposed in a pioneering new paper by the ancient temple. He proposed that in the early days of the universe, there is a fast and intense exponential expansion phase. During this period, the energy of the universe is not distributed in matter and radiation particles. It exists in the fabric of space itself through fields or other mechanisms. This explosion solves all three problems. The universe has the same temperature and density everywhere. It can be interpreted as there is a causal relationship between things in the past. The connection is exploding. The early expansion stage of frying is stretched. The explosion stretched the universe beyond measure. No matter the circumstances of the accident, the visible portion looks flat as it is today. Partly no difference for unipolar self problems. The absence of ancient ruins can be explained. Expansion prevents the universe from reaching arbitrarily high energies or temperature. Expansion, the maximum temperature reached after finishing, avoided the creation of these relics. Inflation theory. Not only does it provide an explanation for these views, the mechanism of measuring phenomena, and it also provides standard calorimeter, a powerful alternative to the explosive model. As other issues are resolved, inflation theory shows how to expand, restore an item after bloating. Homogeneous and uniform early universe. Apparently, inflation can be used as a quantum mechanism. South laws or seeds for the universe. The study of the structure of the universe eventually led to here we are today in the 1980s. Detailed structure observed explosion. The theory makes specific predictions about the seeds of the structure of the universe and testable predictions. These predictions should be in the cosmic microwave background, and the large-scale structure of the universe can be observed for decades. These predictions are made has been confirmed by observations since the 1990s. Real inclusion density. He went approximate but incomplete. Scale invariance of degree fluctuation spectrum and natural fluctuations at ultra-low flat bond scales, and that's beyond what's going on in the expanding universe. With light, fast-moving signal can be hot. The highest temperature created for the universe during the Big Bang. Inflation theory. It offers a different the Big Bang theory of the universe discrimination. The path does not start from a starting point, but through rapid expansion into the Big Bang stage. This is for us about the universe. The profound questions that really began new perspective. Even with this concept, does it apply to a non-explosive exploded universe? It remains an open question. Exponential expansion of the explosion makes it complicated to trace back to a starting point. Reach a state Where the universe is zero in size, it will take an infinite amount of time quantum mastery, generated by the explosion process, the imprint left on our visible universe. These only correspond to the final result. If we want to put the discrimination of the universe push to an earlier period, then explode the previous moment will destroy those hopes. We cannot observe anything that can provide evidence of insight while studying the details of how the explosion worked. The concept of eternal explosion offers a fascinating perspective. Any successful solution to the original Big Bang problem and introduce new quantum effects to solve non-monarchical magic in the universe will lead to such a scene. Although in a country like ours it may have ended in some areas, but in an infinite number of other regions will continue to generate more space. Essentially, once you start there, it kind of became an endless process. He will erase all information about the previous state. It will continue indefinitely into the future. In some individual regions, due to the mastery of quantity characters, similar to the structure of the universe, may end causing the occurrence of a hot Big Bang, but the number of these areas will far less than those areas that last forever. It is worth noting that there are no two separate Big Bang zones. There will be overlap because the expanding universe separates them from each other. Despite the attractive forces, however, the eternal theory also has its limitations. He is considered to be timeless about the future rather than the past. In fact, it has been proven inflated spacetime, not as complete as we used to think. He must have originated from some previous state. This state is non-inflationary and may be unique. Try to steer through bouncing cosmology or cyclic cosmology. Wait for alternatives. To avoid the past, the problem of incompleteness of time has been shown to face similar challenges, but that doesn't necessarily mean that the universe you have to start from the beginning. For example, the sword can be made by scaling the scale factor of the universe magic. Build a structure like the complete spacetime in which expansion occurs, and the inflation is set to be exponential of growth. Add a constant rather than a purely growth index. Our best description of the early universe does not include an absolute beginning. We can infer hot pre-Big Bang matter. The temperature and density of radiation are limited. The universe went through a phase in its expansion process. At this stage, space is filled with energy instead of matter and radiation. It expanded exponentially, relentlessly. Inflation cannot continue indefinitely. He must have an origin, but unfortunately our knowledge of this previous state is limited. Although we can say with confidence, we don't live in a material drift in a universe floating in a vacuum. The universe we live in is an energy field everywhere, and through interaction produced everything we observe. When we think about the vastness of the universe, we tend to feel fear, but in fact, the universe is teeming with activity. Even in a state known as a vacuum quantum long theory, the solid universe is not empty. The fluctuation and interaction of these plants become all around us foundation of the world, including ourselves. We are not alone. It is the product of the interaction of these energy fields. Each basic grain, the children, are all associated with a specific type of plant. By this means, even in the coldest, in the emptiest space, there is also a dynamic energy exchange and transformation. This solidifies the fundamental knot of the universe and our place in it. In the basic framework of physics, rice seeds are the building blocks of all known matter. Children include electrons, up and down quarks. These are the building blocks of atoms and the fundamental building blocks of neutrinos. Fermi, the children interact through three basic interactions: electromagnetic force, strong some force, and weak some force. Electromagnetic force is transmitted by photons, the transmitter of strength, and strength is the proud sun. And if the force passes through W and the C wave, sieve like a sword bridge. Theoretical physicist David Tunn pointed out that without these positions, matter particle would basically float aimlessly through the universe. Lack of interaction, therefore, it lacks any interesting behavioral Higgs field, playing a unique role in this interactive network. Special role. He has been compared to Tang Mi, who is all over the universe, giving mass to other particles, stop them from moving at the speed of light, although the metaphor is not perfect because he suggests friction. But he vividly illustrates various particles, child and Higgs. They often interact in different ways. Actually, all fields in matter and position are universal, but they interact in different ways. Some particles don't interact at all, and other particles are created by interaction reactions and complex structures. When the energy of the quark field is high enough, quark will produce form atoms. Examples of Jauzi and force, put two up and one down, quake binding to proton. than the protons and neutrons. By combining strong forces into atoms, and physicists speculate the universe we can observe contains the ability to withstand virtual particles remnants that are constantly being produced and drowned, although the universe is teeming with virtual particles, but they don't completely reject the idea of nothingness. A universe filled with a vast quantum energy field produces a combination of material forces ultimately created our world. Physicist and cosmologist Lawrence Krauss proposes the entire universe. Maybe it's just a big virtual example. The idea is based on nothingness. It's inherently unstable. Views that generate basic examples. Although this theory has not been proven, but he offered a glimpse into how the universe emerged from interesting perspectives born out of nothingness. We can imagine a universe that would be completely empty. But this does not match the reality revealed by the laws of physics. As long as there is energy, even the zero-point energy of a quantum vacuum, enough to ensure the universe will never be completely empty. Facing the vastness of the universe, we must remain humble, accept that our understanding of the universe is far from complete. Curiosity drives us to explore, ask questions, and unravel the mysteries of the universe, and that's the beauty of physics. He keeps showing us even the emptiest nothingness, also full of possibilities and activities. Thanks for watching. If you enjoyed this video, be sure to like, comment, and subscribe to Galactic Discoveries Quest. Don't forget to turn on the notification bell to get our latest videos as soon as they're out. See you next video.